Hello students, welcome you all. Today we are going to learn a new chapter from Inorganic Chemistry, and the name of the chapter is Complex Compounds or Coordination Compounds. Okay, the name of the chapter Complex Compounds or Coordination Compounds. So let us look at the introduction of this chapter before going into details. Suppose students, if we take solutions of potassium chloride and magnesium chloride. These are well known compounds. So taking the solution of potassium chloride and magnesium chloride. I think you know the formulae of these compounds also. KCl plus MgCl2. So I am telling you, taking solutions of potassium chloride and magnesium chloride. How do we get solutions of these compounds? Only when we add some water to these compounds. Okay. So look at the reaction here. KCl plus MgCl2 plus 6 moles of water. KCl plus MgCl2 plus 6 H2O. So when these solutions are evaporated. What's the meaning evaporated? That means when we heat this solution, okay, when we heat this solution or when we simply mix this solution, we get a new compound called as carnallite. What is this carnallite? KCl, MgCl2, 6H2O. Okay, students. Similarly, if we take a solution of potassium sulfate, K2SO4, and aluminium sulfate, Al2SO4 thrice, and if this solution is evaporated, that means when this solution is heated or simply mixed, we get a new compound called as potash alum. What is potash alum? K2SO4, Al2SO4 thrice, and 24H2O. Okay, students. So when you observe these two reactions, when we are evaporating the solutions or when we simply mix these solutions, we obtain new compounds like carnallite and potash alum. Okay. So these new compounds are called as molecular or addition compounds. Okay, students. So look at the first sentence written over here. When solutions containing 2 or more salts in stoichiometric or simple molecular proportions, when they are evaporated, that means when they are heated or simply mixed, what happens? New compounds are obtained, and those new compounds are called as molecular or addition compounds. Understood, students? So when we take solutions containing 2 or more salts in simple proportions, and when they are heated or when they are simply mixed, we get new compounds which are known as molecular or addition compounds. So under this we have seen two examples. One is carnallite and the other one is potash alum. Okay. Now, so understood what are addition compounds or molecular compounds, students? Now, is it clear? Okay. Now, these addition compounds, they can be classified into two types broadly. Okay. What is that, students? The addition or molecular compounds, they can be classified into two types. The first one of this is double salts. Put the side heading, double salts. What are double salts, students? See, the addition compounds which produce ions when dissolved in water. Suppose if we take an addition compound and dissolve it in water, what do? They produce the constituent ions or expected ions. That means we can expect, okay, these ions will be formed when this compound or when this salt is dissolved in water. Okay, such compounds, such addition compounds are called as double salts. And also you should notice one point, students, they lose their identity when they are dissolved in water. What's the meaning? They lose their identity means what? They do not possess the properties as they possessed before dissolving in water. Okay, that is what we say. They lose their identity when they are dissolved in water. Look at the examples given here. So taking the first example as carnallite, you know the formula of carnallite, KCl MgCl to 6H2O. So how did we get this carnallite? By mixing up or by evaporating a solutions of KCl and MgCl to we get carnallite. Okay. Now when this carnallite is again dissolved in water, what happens, students? It produces the ions like K plus, Cl minus and Mg plus 2 ions. So these are all the known ions. By looking at the compound itself, by looking at the formula itself, we can say that, okay, these ions can be formed when it is dissolved in water. So the same ions are being obtained here. Okay, K plus, Mg plus 2 and Cl minus ions. Okay, students, the addition compounds which produce constituent ions or expected ions when dissolved in water and lose their identity are called as double salts. Okay, so let me move on with few examples more. Second example, K2SO4 Al2SO4 thrice 24H2O. This is called as potash alum. This is obtained by mixing up or evaporating a solution of potassium sulfate and aluminium sulfate. Now, when this potash alum is dissolved in water, so can you guess the ions being produced when this is dissolved in water, students? K plus, very good, Al plus 3 and also SO4 minus 2 ions. Potassium, aluminium and sulfate ions are produced when potash alum is dissolved in water. Okay, next moving on to the third example. This is Morse salt. Morse salt is nothing but NH4 taken twice SO4, FeSO4, 6H2O. So this is obtained by mixing up or evaporating a solution of ammonium sulfate and FeSO4, that is ferrous sulfate. Okay, students, when Morse salt is dissolved in water, it produces the expected ions. What are they? NH4 plus, ammonium ion, Fe plus 2, ferrous ions and sulfate ions. Okay, students. So these are called as double salts, which are nothing but which lose their identity when dissolved in water and they can produce constituent or expected ions. Am I clear, students? Okay. What is the second category of the addition compounds? Second one is complex compounds. What are complex compounds? So this is just the opposite of a double salt. So complex compounds are the addition compounds which produce new ions or unexpected ions instead of constituent ions or expected ions when dissolved in water or any other solvent. Okay, students, understood the difference between double salts and complex compounds? Complex compounds are the addition compounds which can produce new ions or unexpected ions. There what we have seen, constituent ions or expected ions. And also here, students, they do not lose their identity even after dissolving in water. So that's what I have written here. They retain their identity in solution. Okay. Now look at the example, potassium ferrocyanide. What is the formula? K4FeCN6. So when you are dissolving potassium ferrocyanide in water, what is it producing? It is producing a new ion FeCN6 minus 4. Okay, instead of Fe plus 2 and Cn minus ions. Okay, see generally it should produce K plus, Fe plus 2 and Cn minus ions, na students. But when it is dissolved in water, it is producing a new ion, that is FeCN6 minus 4, which is a complex ion instead of constituent ions Fe plus 2 and Cn minus. Okay, hence potassium ferrocyanide is a complex compound. Okay, so these new ions are the unexpected ions. We call them as complex ions. What are they called, students? The new ions are the unexpected ions which the addition compounds are producing when dissolved in water are called as complex ions. Underline this word, complex ions. And the compounds which are producing these new ions are called as complex compounds. Underline complex compounds also. Okay, clear? Now, in complex ions. So here from potassium ferrocyanide, what is the complex ion we are getting when dissolved in water, students? FeCN6-4. Okay, so in complex ions, the central metal ion is generally a transition metal. So what is the central metal ion in FeCN6-4? That is Fe. So it is generally a transition metal, and the anions or the neutral molecules surrounding the central metal ion. Okay, so what are the anions or the neutral molecules having lone pair of electrons surrounding the central metal ion? They are called as ligands. Okay, students, what are they called, ma? They are called as ligands. Okay, so Fe is the central metal and Cn is the ligand. And also in complex ions, the central metal ion and the ligands are bound with coordination bonds. Okay, the bond between the central metal ion and the ligand is coordination bond. Hence, complex compounds are also called as coordination compounds. Okay, students. So now you understood, I guess, why complex compounds or coordination compounds is the name of this chapter. Okay, why they are called as coordination compounds? Because the central metal ion and the ligands, they are bound with coordination compounds. Hence, complex compounds, they are also called as coordination compounds. Okay, students. So this is all about the introduction of complex compounds, under which we have learned what an addition or molecular compound is and what is the classification of addition compounds, under which there are two types, double salts and complex compounds. Double salts means when dissolved in water, they produce constituent or expected ions and they lose their identity, whereas complex compounds, they produce new ions or unexpected ions and they do not lose their identity. Okay, and these new ions are called as complex ions. In complex ions, central metal ion is generally a transition metal, and the anions surrounding or the neutral molecules which possess lone pair of electrons surrounding the central metal are called as ligands. The central metal ion and the ligands are bound with coordination bonds. Okay, hence complex compounds are also known as coordination compounds. Okay, students. So carefully read the classification and try to learn this. Okay, thank you.